Next topic is organ plane and polar representation. Now see, in R square, that is in two-dimensional plane, to represent a two-dimensional plane, we take this coordinate axis, x-axis and y-axis. This is origin. Now, if we discuss about a complex number 3 plus 2y. This is a complex number 3 plus 2y, and there is a point in this plane whose x coordinate is 3 and y coordinates is 2. So coordinates of this point are 3, 2, and this is a complex number 3 plus 2y. So this complex number is related to this point. Point is P. Or we can say point P is related to this complex number. So this complex number can be assigned to this point. Let me take another point. Z equal to minus 4 plus 9. Real part is minus 4, imaginary part is 1. So corresponding to this complex number, in this coordinate plane, we can find a point whose x coordinate is minus 4, y coordinate is 1, and that point is somewhere here. This is a point minus 4, 1. So this complex number is associated with this point, or this point is associated with this complex number. We take one more point. Suppose z equal to 3 plus 0i a plus bi. 3 plus 0i. That means it is nothing but only 3. This is 3. So this is corresponding to point 3, 0. So 3, 0 is somewhere here. 3, 0. It lies on x-axis. So if you represent any real number, this is a real. When imaginary part is 0, z is a real number. So point corresponding to every such complex number which is a real number lies on x-axis. So every point on x-axis is associated with such complex numbers z equal to a plus 0i, where b is 0. So this x-axis is also said to be real axis. If we represent z equal to minus 3i, z equal to minus 3i, it is 0, minus 3. Minus 3i, its standard form is 0 minus 3i. So you can observe this as 0, minus 3. Real part is 0, imaginary part is minus 3. So 0, minus 3, that is somewhere here. This is the point corresponding to this complex number. if you represent z equal to 3i, 3i, that is 0 plus 3i. So this is associated with 0 comma 3. 0 comma 3 is somewhere here. So this number is purely imaginary number because the real part is 0. So point corresponding to purely imaginary number lies on y-axis. So y-axis said to be, it is said to be imaginary axis. X-axis is real axis, y-axis is imaginary axis. If z equal to minus 5 minus 2y, so this complex number, it can be related with point in this coordinate plane minus 5 comma minus 2. So minus 5 comma minus 2, it will be in third coordinate. If suppose I take here minus 1 comma minus 2y, so point corresponding to this complex number is corresponding to minus 1 minus 2y is somewhere here. Minus 1 comma minus 2. So any complex number z equal to a plus ib, there exists a point xy, there exists a point ed in this coordinate plane. So the plane obtained thus is said to be Argand plane. So this is an Argand plane. So putting this everything in general, if z is equal to a plus ib is any complex number, then corresponding to this complex number, there exists a point P A comma B, or simply point A in coordinate plane. The plane obtained thus, the plane obtained thus is said to be Argand plane. So in general, this line is imaginary axis, this line is real axis. Here x-axis is the real axis and y-axis is the imaginary axis. This is origin. It is said to be pole. Now, if this point is A comma B, then it is corresponding to A plus BI. So that is the meaning of Argand plane. It's nothing but exactly similar to plane in two dimension in which every point is represented by coordinates So same procedure we have performed here. Complex number is a plus bi. So consider this a plus bi as a comma b. So connection between complex number and point in coordinate. So this plane is said to be Argand plane. Now polar representation of complex number. Say this line is imaginary axis, this line is real axis, this is origin. For z equal to a plus ib, corresponding to z, this is a point whose coordinates are a. Now, joining this point with the origin, this is a directed line segment. Red OB, it shows directed line segment. Now, here, taking the perpendicular from P on x-axis, if you observe that foot of perpendicular, because it lies on x-axis, here this length is, it will be modulus A, because x coordinate is A. This length will be modulus of B, because y coordinate is B. I am putting modulus because length is always positive, while coordinates can be negative. If a point lies in second quadrant, then this number can be negative, but length is positive. So taking modulus. So by right angle triangle, this length will be, it is equal to square root of a square plus b square. And this is nothing but modulus of this complex number. It is modulus of z. So remember, modulus of any complex number, it is length of line segment OP. So it is a modulus of complex number. So if corresponding to z equal to a plus ib, point A, Argand plane is PAB. Here, modulus of z, it is equal to root a square plus b square. It is nothing but length OB. Let me denote. Modulus of z is r. Suppose that this length is r. And angle POX, equal to theta. So theta is angle made by this line segment OP with x-axis. So this is the theta. So this theta is said to be argument of complex number z. Here theta is said to be argument of complex number z. In short, argument of z is equal to theta. Now see, if suppose this is x axis, this is y axis. If point P is here, this is directed 9 second. So this theta, value of theta, it is in second quadrant, more than pi. If P is somewhere here, then theta can be this number. It is in third quadrant. If P is somewhere here, then theta can be this angle. So during first rotation, that means theta will take in 0 to 2 pi. Value of theta can be in any interval of length 2 pi. So here theta can be taken 0 to 2 pi. But in this discussion, we will take theta in interval minus pi to pi. Say, instead of taking this first rotation, the rotation can be taken by this method also. See, this is x-axis, this is y-axis. Theta we are allowed to take from any interval whose length is 2 pi. Here length is 2 pi. You can choose interval of length 2 pi by taking minus pi to pi. So this is minus pi to pi. So instead of 0 to 2 pi, if I take here minus pi to pi, then theta is said to be principal argument. So instead of 0 to 2 pi, we are taking here minus pi side we keep open, pi side close, minus pi to pi. So if theta belongs to open minus pi, close pi, then theta is said to be the principal argument of set. It is simply denoted as argument of set. It is simply denoted as argument of set. See, pi is included, so minus pi is excluded. Otherwise, point will be limited, because point corresponding to minus pi and point corresponding to pi is same. We include every point one and only one time. See, if suppose complex number, point corresponding to complex number is in fourth quadrant. This is in fourth quadrant, then this will be ray OB. In this case, we can take theta from theta along anti-clockwise direction. This is allowed. This is true. You can take theta along anti-clockwise direction. So in this case, theta will be in fourth quadrant. But now we are going to take theta in this interval. If you take theta in this direction, if point is in fourth quadrant, then this theta does not belong to this interval. So to get value in this interval, what we will do? We will measure theta in clockwise direction. So this will be negative, and this negative will be included in this interval. If point is P is somewhere here, then this will be directed line segment OB. In this case, theta will be measured in clockwise direction. So these values of theta, it will be included in minus pi to 0. And if a point is in first quadrant or point is in second quadrant, then theta, it will be measured in clockwise direction. So 0 to pi. And for this point P is here, theta will be in pi by 2 to pi. Point is in first quadrant, then theta will be, this theta will be in 0 to pi. If point is in second quadrant, theta will be in pi by 2 to pi. If point is in fourth quadrant, theta will be in minus pi by 2 to 0, negative side. If theta is in third quadrant, point will be in minus pi to minus pi by 2. So here it covers interval of length 2 pi. Theta taken from this interval is said to be principal argument of Z. Here numbers, real numbers r comma theta are said to be polar coordinates of point P. Polar coordinates of point P. And this complex number Z equal to A plus IB can be expressed as here polar form of Z equal to A plus IB is, this complex number can be expressed as modulus R comma cos theta plus I sin theta. This complex number can be expressed as modulus R into cos theta. Here you can see that this will be modulus R cos theta and this will be modulus R sin theta. From this right angle triangle, this is R. Modulus Z we are denoting as R. So value of A will be modulus R cos theta. Sorry, no need to show here modulus. R itself is positive, so we simply put R. R itself is positive because it is modulus. So either you keep either a modulus Z or keep R, because R is modulus Z. It is root A square plus B square. And in theta, theta is argument of Z. So theta belongs to open interval minus pi to pi, or you can take theta from any interval of length 2 pi. So this is polar form of complex number Z. Find the modulus and argument of following complex numbers, express them in polar form. So here Z is A plus BI. So comparing with A plus BI, A is minus 1 and B is minus root 3. A is minus 1, B is coefficient of I, that is minus root 3. First of all, we find modulus. Modulus of Z is root A square plus B square. So root A square plus B square, that is square root of minus 1 square is 1, minus root 3 square is 3. So this is 2. Modulus of z is 2. So that means this is modulus of z. Now we want polar form. Polar form. Look, to find polar form, we want to find its argument. Just discuss the theory part that z equal to a plus ib. Polar form of z equal to a plus ib is z equal to modulus r cos theta plus I sin theta, where r is, here we don't keep modulus, r is modulus of z, it is root a square plus b square, that we have found, and theta is argument of z. This theta can be found, it can be found by cos theta equal to a by r, sin theta equal to b by r. So this theta we need a minus pi to pi. So to find theta, it can be found by cos theta is a by r and sin theta is b by r. So look here, mod z is 2, it is modulus, therefore r is equal to 2. That we substitute, we will substitute in that formula. Now, if argument of z is theta, then cos theta is a by r, sin theta is b by r. Procedure to find theta. If theta is argument of z, then cos theta is a by r, sin theta is b by r. Therefore, cos theta is a is minus 1, r is 2, sin theta is b is minus root 3, r is 2. Both are negative. So cos is negative, sin is negative, so theta lies in quadrant 3. And it should be from this interval, quadrant 3, and belonging to minus pi to pi. This theta, it should be from minus pi to pi. So to find value from minus pi to pi, take help of unit circle. If suppose both are positive, think about positive. X positive, Y positive. For few seconds consider both are positive. Cos is 1 by 2, sin is 1 by 2. Then obviously you know theta corresponding to this point is pi by 3. So this is pi by 3. But here both are negative, so point will be exactly on opposite side. It will be exactly on opposite side. Point corresponding to point in first quadrant, opposite to point in first quadrant, it is somewhere here. This was pi by 3, so this is also pi by 3. This is pi by 3. Now 1 by 2 root 3 by 2, so this will be minus 1 by 2 minus root 3 by 2. Theta correspond to this point because cos theta is minus half, sin theta is minus half. So we have to theta because point is in third quadrant, take theta in clockwise direction. So this will be minus 2 pi by 3. It is minus pi plus pi by 3. That is minus 2 pi by 3. So theta will be minus 2 pi by 3. So argument of z is theta is minus 2 pi by 3. This is principal argument. Always we will take from this interval. Whatever you put your value of theta, it must belong to this interval. Then we can say it is principal argument. After getting theta and value of r, now we substitute this value in polar form. So polar form of z, therefore polar form of z is z equal to r into cos theta plus I sin theta. Therefore r is 2 cos theta, so cos of minus 2 pi by 3 plus I into sine of minus 2 pi by 3. So z is r into cos theta plus I sin theta. It is said to be polar form of z. So this is the method. Now see, exactly similar method we perform here to find r and theta and its polar form. Again, repetition of this procedure. Here, a is minus root 3 by 2. Sorry, a is minus root 3 and b is coefficient of I, that is 1. Real part is a and imaginary part is b. First of all, we find modulus. Modulus of z is root a square plus b square, that is root 3 plus 1. Again it is 2. So modulus of z is 2. So this is r is 2. Now, if argument of z is theta, then theta should be in this interval, open minus pi to pi. Then this theta can be obtained by cos theta is a by r and sin theta is b by r. Cos theta is a by r, sin theta is b by r. So cos theta is equal to a by r minus root 3 by 2 and sin theta is b1, r is 2, 1 by 2. Therefore, now say cos is negative, sin is positive. Cos negative, sin positive. So theta lies in quadrant 2. So we will find the corresponding value of theta in quadrant 2 and theta should be in this interval. Because point lies in quadrant 2, theta will be majorly anti-clockwise direction. If point is in first and second quadrant, go through anti-clockwise direction. If a point is in third or fourth quadrant, take clockwise direction, means take negative value. So here, cos is minus root 3 by 2, sin is 1 by 2. To find the corresponding theta, let me take help of unit circle. If these both are positive, then point will be somewhere here. Root 3 by 2, 1 by 2. If cos is positive, sin is positive, then this theta will be pi by 6. But cos is negative, sin is positive, so corresponding point will be exactly on left side. This will be minus root 3 by 2, 1 by 2, which values we are having. So theta corresponding to this point will be pi minus pi by 6. So this will be 5 pi by 6. So theta is, therefore, theta is 5 pi by 6. So argument of z is, therefore, argument of z is 5 pi by 6. And its polar form, and polar form of z equal to a plus ib is z equal to, formula is r into cos theta plus I sin theta, that is z equal to, r is 2 into cos of 5 pi by 6 plus I into sine of 5 pi by 6. So this is polar form of this complex number. So to find a polar form, we use this method. So z is minus 3. This can be expressed as minus 3 plus 0y. So a is minus 3, b is 0. So here r is, modulus of z is root a square plus b square, that is 3. So modulus of z is 3. Now for argument of z, if argument of z is theta, then cos theta is a by r, sin theta is b by r. So cos theta is, e is minus 3, r is 3, sin theta is, b is 0, r is 3. So cos theta is minus 1, sin theta is 0. Cos is minus 1, sin is 0. That means point lies on x-axis. So here on number line, on this unit circle, cos theta minus 1. This point has x coordinate minus 1, and here sin theta is 0. So if cos theta is minus 1, sin theta is 0, then theta is, either we can take minus pi or we can take pi. But according to condition, it should be belonging to open minus pi, close pi. So we take theta equal to pi. So here theta is pi. So argument of z is pi. And polar form of z is modulus r into cos theta plus I sin theta, that is modulus r, sorry, they put here r, only r. If you want to use modulus, keep modulus z. Either we keep modulus z or r. So r is equal to 3 into cos of minus pi plus I into sine of minus pi. So this is polar form of given complex number. Now, for z equal to y, here E is 1, z is 0 plus 1i. Z is 0 plus 1i, that means E is 0 and D is 1. A is 0 and B 1. So modulus of Z, that is R, is equal to modulus of Z is square root of A square plus B square, that is 1. So modulus is found. Now, if argument of Z is theta, then cos theta is A by R, sin theta is B by R. So cos theta is 0 by 1, sin theta is 1 by 1. So cos theta is 0, sin theta is 1. Cos 0 and sin 1. So point is here. This is the point whose x coordinate 0, y coordinate 1. So here cos theta is 0, sin theta is 1. This is unit circle. See, everything we are getting from unit circle. So corresponding to this point, theta is pi by 2. So here theta is pi by 2. So argument of z is pi. And polar form of z is z equal to r into cos theta plus I sin theta. That is z equal to r is 1 into cos pi by 2 plus I sin pi by 2. So this is polar form of given complex number. Say, always remember, if z is a real number, if it is negative real number, then argument of z will be always pi. If this is a positive real number, then argument will be 0. If here real part is 0, imaginary part is any positive real, so argument will be pi by 2. And if z has imaginary part negative, if this number is negative, then argument of z will be minus pi by 2. Now in this question, we find argument, modulus and polar form. To find argument, modulus, polar form, we have to convert this in standard form. So first of all, converting this in standard form, z equal to 1 plus 2y upon 1 minus 3i. So multiply and divide by 1 plus 3i, 1 plus 3i. Multiply, divide by conjugate of denominator. So this will be 1 minus 9i square. Numerator will be 1 plus 3i plus 2i plus 6i square. That is 1, this is minus 6. 1 minus 6 is minus 5 plus 5y upon 1 minus 9. So this will be 10. So it is minus 5 plus 5y upon 1 plus 9 is 10. So it is minus 1 by 2 plus 1 by 2y. Z is minus 1 by 2 plus 1 by 2y. This is complex number Z. So we have converted this into standard form. And now, after converting in standard form a plus bi, we perform this procedure. So here, a is minus 1 by 2, b is 1 by 2. So modulus of z, or it is r, is root a square plus b square, that is square root of a square is 1 by 4, b square is 1 by 4, so it is square root of 1 by 2. 1 by 4 plus 1 by 4 is 1 by 2. So this is 1 by root 2. Modulus of z is 1 by root 2. Now, if argument of z is theta, then theta can be found by cos theta is a by r, sin theta is b by r. So cos theta is a is minus half, b r is 1 by root 2. Sin theta is b is 1 by 2, r is 1 by 2. So cos theta is minus 1 upon root 2, sin theta is 1 upon root 2. You can see that axis cos theta is negative, sin theta is positive. On unit circle, to get theta corresponding to these numbers, cos negative, sin positive. If both are positive, then point will be somewhere here. If both are positive, 1 by root 2 plus 1 by root 2, then theta will be pi by 4. But x value is negative, that means x coordinate. This is negative. Second value is positive, it is cos theta, sin theta. This is cos theta, this is sin theta. So theta will be in second quadrant. Because point in second quadrant, we measure theta along anti-clockwise direction. So this is pi minus pi by 4. So it is 3 pi by 4. So theta is 3 pi by 4. So argument of z is 3 pi by 4. Therefore, polar form is z equal to r into cos theta plus I sin theta. That is z equal to r is 1 by root 2. 1 by root 2 into bracket cos of 3 pi by 4 plus I into sin of 3 pi by 4. So that is required polar form. Now z is 1 plus 7i upon 2 minus I whole square. To obtain argument of z or modulus, we convert this in its standard form, z equal to a plus bi. For that, simplifying this, z equal to 1 plus 7i upon, this is 2 minus I whole square. Its expansion is 4 minus 4i plus I square. It is equal to z equal to 1 plus 7i upon This is 4 minus 1. This is 3 minus 4i. Now once again, multiply and divide by conjugate of denominator. We continue simplification by this method until we get denominator free from I. So because still there is I, after simplification, we multiply and divide by conjugate of denominator. So 3 plus 4i. So Z is, this is 9 minus 16i square. Numerator is 1 into 3, 3 plus 4i plus 21i plus 28i square. That is Z equal to 3, this is minus 28. 3 minus 28 is minus 25 plus 25i upon, this is 9 plus 16. So Z is minus 25 plus 25y upon 25. So Z is minus 1 plus I. So this is simple form of Z, standard form. So its modulus is, therefore modulus of Z is square root of, here A is minus 1, B is 1. A minus 1, A is 1. So Z is, modulus Z is root A square plus B square, root 1 plus 1, that is root 2. We say is R. R is root. If argument of Z is theta, then cos theta is A by R, sin theta is B by R. So cos theta is, E is minus 1, R is root 2. Sin theta is 1 by root 2. B is 1, R is root 2. And just discussed in last question, values are same. So theta is 3 pi by 4. So this is argument of Z. And polar form is Z equal to R into cos theta plus I sin theta. That is, Z is, in this question R was different. Root 2 into cos of 3 pi by 4 plus I into sine of 3 pi by 4. So it is polar form. Because here this polar form and argument was required, we have converted this in A plus BI. A plus BI form is required to find cos theta and sin theta. Because A and B, these separate values are required. But if, suppose, if you are asked to find only modulus, if you are not asked to find argument, but if you are asked to find only modulus, then there is one more method to find modulus. So here Z is 1 plus 7i upon 2 minus I whole square. Without converting into A plus BI form, we can find modulus. Modulus Z is modulus of 1 plus 7i upon 2 minus I whole square. That is, modulus of Z1 upon Z2 is modulus of Z1 upon modulus of Z2. This is equal to 1 plus 7i upon, this will be, it is modulus of z square. Modulus of z square is modulus z whole square 2 minus I. And now 1 plus 7I, its modulus is 1 plus 49. And here square of modulus of this number is square root of 4 plus 1. A square plus b square. B is minus 1. So minus 1 square is plus 1. So it is equal to root 50 upon root 5. Root 5 square is 5. So it is 5 root 2 upon 5, that is root 2. So modulus can also be found by this method if you want only modulus. But if you want argument, you have to convert in a plus bi form. Solution of a quadratic equation. If ax square plus bx plus c equal to 0, this is a quadratic equation if coefficient of x square is not 0. This is non-zero, then it is quadratic equation. Now to find the solution, we find a discriminant. Discriminant is b square minus 4ac. And you know that if b is more than 0, then equation has two real roots, two distinct real roots. Roots are minus b plus root d upon 2a and minus b minus root d upon 2a. If b is equal to 0, if discriminant is 0, then equation has two identical roots, or we can say only one root, and it is if d is 0, if you give here 0, then root is minus d by 2a, and if d is less than 0, then equation has no real roots. But we can say that this equation has two distinct complex roots. If discriminant is more than 0, then two real roots. But if less than 0, then real roots does not exist. But it has complex roots. So complex roots are minus b minus root d upon 2a and minus b plus root d upon 2a. By the same formula, which was for real roots, same formula is for complex roots. And here, these two complex numbers will be conjugate of each other. This will be conjugate of each other. Let me find roots for this quadratic equations. We solve these equations. Say here, A is 2, B is 1, C is 1. So D is B square minus 4A into C. So it is minus 7 less than 0. D is less than 0. So complex roots are, this equation has complex roots. If d is less than 0, then equation has complex roots. So complex roots are minus b plus minus root 3 upon 2a minus b plus minus root 3 upon 2a plus or minus. We are showing combined roots. That is minus b is 1 plus minus square root of minus 7 upon 2 into a. So that is minus 1 plus minus root of minus 7 is square root of 7i. Square root of minus 1 is root 7i. Square root of minus 1 is I upon 4. Therefore, minus 1 plus root 7i upon 4 and minus 1 minus root 7i upon 4 are required roots. These are complex roots, and you can see that both are conjugate of each other. For this question, here a is root 3, b is minus root 2, option of x is b, c is 3 root 3. Discriminant is b square minus 4a into c. b is minus root 2, a is root 3, c is 3 root 3. So it is 4 root 2 square, that is 2, minus 4 into 3, 12, 12 into 3, 36. So it is minus 34, and this is less than 0. D is less than 0, so it has complex roots. Therefore, this equation has complex roots, and roots are minus b plus minus root b upon 2a minus b plus minus root b upon 2a. Putting values, minus b is minus root 2 plus minus root minus 34 upon 2 into a. So this is root 2 plus minus root 34i. Root 34 into minus 1. For root minus 1 we keep I, and 34 with radical sign keep as it is. This is plus minus upon 2 root 3. Now from numerator, root 2 is common. So 1 plus minus root 17i upon this 2 can be expressed as root 2 into root 2. 2 is root 2 into root 2. This root 3 as it is. So this can be cancelled. So it is 1 plus minus root 17i upon root 6. So these are required complex roots. So it is equal to 1 plus root 17i upon 6 and minus 1 minus root 17i upon root 6 are required roots. Now for this question, so here a is 1, b is minus 2, c is 3 by 2. Discriminant is b square minus 4a into c. So this is 4 minus 6, it is minus 2, it is less than 0. Therefore, complex roots are minus b plus minus root b upon 2a. So minus b is minus 2 plus minus root minus 2 upon 2 into 1. So this is 2 plus minus square root of minus 2 is root 2i. upon 2. So this can be expressed as 1 by 2 plus minus 1 by 2I. So therefore, it is equal to 1 by 2 plus 1 by 2I and 1 by 2 minus 1 by 2I. These are required